Here we have a classroom filled with students that are patiently awaiting for the bell to ring so that they can enjoy their first day of summer. As you look at each student, you can see that they are calm. Some are laid back in their chairs and others are scrolling through their phones. This can't be compared to resting potential. They are all calm, but they know what will be happening in the next few minutes to come. The students calmly sit at their desks, listening to the teacher talk about neurons even though it's the last day of school. The all or none law can be exhibited here because although the students know that summer is just a few minutes away, they cannot make the time go any faster. But then the students begin to stare at the clock. The threshold of excitation happens when the students begin to chant as it gets closer to 2:30. The time creeps closer. There's only one more minute. They're almost at the edge of their seats in excitement. They're toppling over, and then it's 2:30 now. The action potential has been reached. The students all jump in the air. The students don't waste any time to run out of the classroom. This symbolizes the release of neurotransmitters finding their receptors, and in this case, it's their summer plans. Now let's take a moment to see what's actually going on. When a neuron is unstimulated, it is at its resting potential. During resting potential, the neuron is more negatively charged on the inside. Since it's more negatively charged on the inside and positively charged on the outside, there is a difference of negative 70 millivolts in the neuron. As you can recall from this clip, this is when the students were at their resting potential, when they were all laid back, on their phones, just calm and waiting for action. When triggered by a certain stimulus, the potential inside the neuron can be made less negative, which will then cause the neuron to reach the threshold of excitation. Flashback to when the students were chanting summer. This is when they reach the threshold of excitation. Once it reaches the threshold of excitation, the action potential is then triggered. Once the action potential is triggered, the inside of the neuron becomes more positively charged and the outside becomes more negatively charged. When the neuron becomes more positively charged on the inside, it is called depolarization. This is because sodium, a positively charged ion, is rushing inside the neuron. Do you remember when the students were throwing their papers in the air? They had just reached their action potential there. In its final stages, the neurotransmitters are then released so they can bind to the receptor sites. And as how the students showed, this is what I would picture the neurotransmitters being released. The all or none law states that the action potential cannot be rushed to begin or rushed to end. The process will never change, just like how the students awaited for the clock to hit 2:30. You cannot speed up time, no matter how hard you try or how strong the stimulus is.